Hi, my name is Victor, and in this video I'd like to talk about two build tools, Lerna and NX. Lerna is a fairly well-known tool in the React community for managing monorepos, right? A lot of folks either heard about it or even used it. And NX is another tool for managing monorepos. It does it in a slightly different way, and hopefully by the end of this video you will see if one of them is a better fit for your project than the other one. So to compare the tools, we're going to use this very small repo, the Lerna repo, with two packages. Okay, there is an application package. It's a React app. What it does, it doesn't really matter. It doesn't do very much. The important thing here that this app consumes the other package code header. Okay, that's what we the only relevant part here. Okay, and this app has a bunch of scripts. We can test the app, we can build it, and we can serve it. Okay. The another package here is header. Once again, the header itself is irrelevant. Just some component, just a chunk of code we need to build. Okay, we can imagine a much larger package in place, and we can test this package in JS to build it using rollup. Okay. So we have two packages in here, right? We have app and we have header. But what we imagine, of course, is not a repo that looks like that. That's not very interesting, right? So what we're imagining is a repo that looks more like this, right? Where we have a handful of applications built out of many app-specific libs, and that also can share some code. Okay. And why you want to build stuff like that is sort of beyond the scope of this video, right? You can read up on monorepos, to get convinced that sometimes this is valuable. Just to highlight a few things that we can talk about is that it allows you to easily share code between your different applications or sort of micro frontends. And because you can partition your app into a lot of libs, you can develop those libs individually, sort of by themselves, right, independently, which helps you as a developer to just reason through what the app is doing. But also, it means that you can try to reuse the result of building those libs and make your build system a lot quicker. So usually if you do things like that, and if you do it intelligently, you can build much larger systems this way, right? And then naively just building one app, right? And bundling that app using Webpack, okay? So those are the two reasons. So this is what we have in mind, right? The trade-offs, etc., all apply to this picture, right? This is just an illustration, right, that we have, okay? So we have this repo, two packages, nothing special, okay? Let's see what we can do with those packages. Like the first thing we can do is we can test the packages. Like normally in a mono repo, there is a way for us to invoke the same target against the same script against a variety of packages. In this case, we're saying, hey, I would like to test everything, right? In this case, Lerna spawns two processes, run the test, collect the results back. We can do the same with the build. And the build is tricky in here because the build requires us to topologically sort the packages, right? The header has to be built first, and the app has to be built second, and we can see the result here, right? The header has to be built into this folder, which is then consumed to build the app. That's the order matters, basically, right? And Lerna is actually a very flexible tool for managing, repos with a handful of packages. We can run the same target against all the packages. We can scope it to a subset of packages. There are quite a few things we can do to manage the repo, right? So that's what we have. So we can test stuff, we can build stuff. That's cool. One of the things I want to point out that in this setup, where we want to reuse the result of computing things before, that can get tricky, is that we cannot naively do things. That's the wrong one. Let's open package.json for the app. We cannot naively do things like this, right? So if we do things like this, Lerna is going to link all the packages, and the header in this case will point to the source, right? So in this case, when Webpack builds the app and it encounters the import from the header, it's going to actually import some source in here, which is problematic for a variety of reasons. Yeah, it affects performance negatively, etc. The build performance, that is. but also mean that we have to build everything using the same sort of preset, right? For instance, the TS config in here in this header can be different from the TS config over here, right? Things like that just do not work well when you have a large team and you actually want to scale your project to a much larger setup. Okay. So we cannot do that. So that doesn't work in practice for anything non-trivial, right? You actually have to build things and depend on the dist. So you could do this. That does work. The build works correctly. But the downside is that if I open my app, right, and I see this import, and I try to, and I try to tell the editor, hey, go to this header package. It cannot go. It doesn't know. So the editor and the language service in this case doesn't know that this header points to this header folder. Right? From the language services point of view, from the point of view of the editor, that's just an import that points somewhere else. Okay, and that's problematic not just because you cannot click around as a human being, but because you like if you want to rename this or find usages and do all the things you normally do in a say in the VS Code setup or in the WebStorm or whatever, those things won't work well, right? Or won't work at all, right? And that's a problem in that there are two contexts in general we have to worry about when we're developing. There's the context of the editor or the human being looking at the code, where we only care about the source, and there is the context of the build, right, which cares about this dist folder over here, right? The two contexts in this naive setup do not work well together. You either benefit, like basically pick one that works well. In this case, we pick the build process because it's more important for us. But the editor sucks, right? We can reverse it, make the editor work, but then the build will suck, right? And it is possible to get it right with Lerna, to make both work. So it's not the inherent issue with Lerna per se. It's just something to be mindful of, that all the things you see, we're like, oh, just put a star and package the JSON. Okay, that doesn't work, okay? So that's what we have. We have a Lerna package, a Lerna repo, sorry, with two packages, the app and the header. We can test both of them. We can build both of them, okay? So now, what we want to do next is we want to create a new annex repo that will be very similar to this one, right? We just scaffold it from scratch. We'll look at some dev ergonomics that we are going to get there, right? What's going to be better, etc. Right? We'll compare the two, and then once that is done, we're going to try to move this repo to Annex and see how challenging it is and what kind of things we're going to get after doing that. To create a new Annex workspace, we need to run npx create Annex workspace command. We can give it a name. We can select what we want to see in that workspace. If we select React, for example, Annex is going to install the React plugin. Annex is a pluggable build tool, and create a React app using it. We can select Next.js, etc. In our case, we're going to select the open source setup. It just changes the layout a little bit to match what we see in a Lerna case. Right? All of this can be changed later on, so it's not an important decision. Here it's asking us whether we want to connect to Annex Cloud, which is basically the cloud companion for Annex. We don't have to, but in this case, we will, just to show you a few extra features you can get, right, when you have a more integrated dev environment. So what we have here is an empty Annex workspace, right, where we're going to create our application and our library. They're going to go to the packages folder. Right now it's empty. The workspace, the JSON file, is a file that contains information about all the projects in the workspace, what we can do to them, etc. Right? So we're going to create a React app. There are many ways to do it, but since it's sort of a very vanilla app, we can use the React plugin. There are a bunch of plugins you can install for different technologies, and some of them are created by the core team, some by the community. We're going to use one created by the core team. If we run an X list, we can see some instructions on what to do to get the plugin ready. Right? We can get the plugin installed. So after we install the plugin, we can see what the plugin offers. And in this case, we can see that the plugin has a few schematics. Schematics is basically a fancy way to call a code generator. Okay, a few code generators we can use to set up the plugin. Right? The one thing we're going to run first, we're going to run the init schematic. We normally don't have to do it; it's run for us. But in this case, I'll do it just to make it to move very slowly, so there is less going on with the repo with every step. So if I did it, now we can see there is some configuration updates, minor things happen to the repo, some global configuration files have been created that are used by React apps and React libs. Right? There is nothing to worry about. Now with this in place, we can create the app. Okay, to create the first app, we can type in an xg application app dry run, right? And the dry run flag over here is one of the coolest features of the code generation provided by NX. NX comes with its own virtual file system, so you can run generators as I do right now, and it can show you what it's going to do without actually touching your file system. In this case, it tells me it's going to do a bunch of stuff. It looks pretty cool. So you can play with different options and see what exactly you need to provide, right, to generate what you need for your feature or for your project, right? The coolest thing here is not doing this in the terminal. That does work. There is also an NX integration for VS Code over here called NX console. So if I choose to use it to generate stuff, right, I have the same schematics available to me. I can select one, say I want to generate an application. And in here, I can see this form. This form is derived from the metadata provided by the React plugin, right? None of it is hard-coded in the VS Code integration, right? One of the key things that separates NX from any other JavaScript or tools for building JavaScript projects is that it's NX is meant to be toolable because we, the core team, came out of Google, so toolability is a big deal for us, right? So a lot of the stuff you see here is built in a way where editors and other tools can take advantage of it, okay? So this stuff is generated based on the metadata provided by the plugin. It's not hard-coded, right? So if I punch in the same name for the app, I can see the preview of my app appearing over here and like, oh, that looks pretty good. And I can play with different flags to decide what I want to do. For example, if I like JavaScript instead of TypeScript, I can select this flag and get JavaScript instead of TypeScript, right? And I can see again what's going to be created. Let's unselect that. I actually believe in TypeScript, and the integration, the support for TypeScript in NX is very, very good. So we have that. It looks pretty good, right? So we can click on the generate. And with this, it still asks us a bunch of questions. We are going to get our app created in the packages folder. We can ignore the end-to-end test for now, okay? The app is very simple. Sort of, the layout is slightly different from what we saw in the Lerna repo, but fundamentally it's the same, okay? We can close that, right? And so that works. Another thing that has been updated is the Workspace.json file. So we got this record for projects, and we have our app, have some information about it. But the important part in here is this section where we can see different targets defined for this project. And a target in this case is sort of similar to a typed npm script, right? So we can build the app, we can serve the app, we can test it, we can lint it. And when I mean typed, I mean that, again, there is some metadata that comes with, in this case, the jest support, right? That we can use to, like ask for help, search for options, but also to do things like, let's say, app, and I can see all the flags that I can, pass to the jest target, right? That's what I mean by typed, okay? So all the things are created in here. Okay, that's cool. So we have our app in there. Let's create our lib. We can call it header, so it matches the Lerna repo. So we have right now our app over here. We have our lib over here. So both of them are created. We can easily use right now our app from our lib, right? If we open the app tsx and let's delete everything we don't care about. We can import. One thing I need to do because I create a new lib restart here server, doesn't really matter. And I can import my header component and use it over here. Okay. The important thing to note is that so I have this package, the lab just created. I don't have to configure anything, right? I can simply import it in my app, and that part works, right? So the import works, and what's important is that if I click on a header, I actually go to the source. All right, so the editor experience is correct. Then I can navigate around. I can also find usages for this header, right? I can rename the header. I can do all the things I expect, right, from a tool like, say, like VS Code or WebDRAW, right? So all of this works. The editor experience is correct. So I have my app, I have my header. Both of them work, right now. So now with these two created, what can I do to them? Right, in Lerna, we try to test both of the projects and we try to build them, right? Let's do the same. In NX, the command looks a bit different, but fundamentally the same. We're just saying that we want to run many targets. We can provision the target we want to run. We can specify the projects. In this case, we're talking about all the projects, and we want to do it in parallel, right? We do that. It's going to spawn two processes, and it's going to run the targets, right? And we can see, everything is okay. I didn't save this one actually. So if I do it again, the test, I believe, is going to fail. Yeah, it's going to fail because I need to update the stack here, right? Okay, so what I have right now, right, is the tests work in a way that's very similar to Lerna. It's already better, and I'll show what I mean in a second. But fundamentally, we can run the tests, right? Can we build stuff? Okay, let's look at that. Okay, so let's try to build stuff. Okay, we can again do the run many, and so that works. But there is a different way to invoke run many, which I'm going to show you in a second. But we can say, let's try to build our app. If we type in a next build app, it's not going to build everything, right? It's going to try to build one app by itself in isolation. And if we do that, we are going to see an error, right? And the error is telling us that we cannot build the app because the header hasn't been built, right? And that's because even though the editor experience goes against source, the plugin we have in here makes sure that when we actually build stuff, because the header is a buildable library, right? The header has to be built first, and then it's going to remap where the resolution, how the resolution happens to import the header from the disk, right? We have to build the header first. We could build the app with all its dependencies, which essentially means the following, right? It means that NX is going to look at the app, it's going to analyze the dependency graph of the app, and NX constructs the dependency graph not by your telling NX, as you do in, say, Lerna. It actually analyzes your source code. It looks at all the imports, it looks at dynamic imports, and it constructs this graph, which you can recommend. And so it's sort of without any configuration. And so when you do these steps, it uses information about the graph to topologically sort the nodes, to figure out basically what needs to be built first and what's later. It sort of sorts it out, build what it can in parallel, and then eventually it will work its way up to the app itself, right? So in this case, if I do this, I'm going to see that the app is being the header has been built first, and then my app has been built, right? And it is successful. Okay, cool. One thing I want to point out that perhaps I didn't draw attention to, but you might have already noticed, is that if I do the build again, right, and you probably saw it in tests, the result will be instant, right? And you'll see that note in here saying the cached output. That's one of the key features that separates NX from a lot of popular open source tools, right? And it's a lot more similar to what you see in sort of in build tools used at Google or Facebook or Twitter, right? Where the core property in that, because they build such large systems where you cannot rebuild everything every time. That just is not an option, right? you have to look at what you are going to do, what computation you need to run. If something like that has already been computed, you can reuse it. In this case, the whole thing has been computed, so it's already used. If I change my app, for example, and introduce epic change to my app and rebuild it again, it looks same graph, it's going to do the same kind of analysis, etc. In this case, it's going to rebuild the app itself, but it's not going to rebuild the header, as you can see, it says over here, right? And that's a very important property, right? In that I don't have to think about it. I didn't have to tell the app that it depends on header, figure it out. And obviously it figures out with 100 projects as well, right? But also I don't have to figure out what has to be rebuilt. And I can just say rebuild everything. In this case, doing this is analogous to doing this, right? So it's the same, right? And it's still all cached in this case, right? Because we just computed that. What exactly Annex does to figure out when something needs to be recomputed is an interesting thing. It's there's a lot of sophistication there you can read up online. But fundamentally, it looks at stuff. If it's the same, if you're trying to do the same stuff against the same code base with the same environment, it can reuse the results. Okay? You will be surprised how often what you build, right, has by and large been built by someone else before you, right? So once you embrace this sort of mindset, most of the time you're rebuilding a small fraction of the system because you are changing only a small fraction of the system, right? You're not refactoring everything every single time, right? Another cool thing in here that this computation cache obviously works for like test app with them for other targets, right? In this case, I'm testing my app. Know that the app is being tested because this version of the app hasn't been tested before, but the header, which is part of the depths, hasn't been tested, was retrieved from cache because the version of the header we have has already been tested, right? So it works for all targets, so it's actually quite handy. The cool part in here that if I remove right now my local cache, this is where the cache of artifact is stored, right? And I try to do the same and say, okay, let me build it again, all right? The question is, will it work, right? In this case, the answer is yes, right? It's going to retrieve the artifacts, and it's going to retrieve them from cloud, right? So again, the cloud part is optional, but if you choose to opt into it, what you get is a beautiful property where if you build something or test something or whatever, right, and your coworker Susan wants to do similar stuff, she can use the result of your computation instead of recomputing stuff from scratch. And it includes CI, meaning that if I pull the main branch in the morning and I try to test stuff or build stuff, it's going to be instant, right? Because the CI has just built and tested everything, right? So it's a really cool property that once you really embrace, right, can yield substantial gains in terms of your productivity, right? And you can build much larger systems this way than sort of naively invoking one Webpack process, okay? So that's what we get with Annex. Okay, there are a couple of other things I can talk about and I can show. For example, similar to Lerna, Annex can figure out what your PR is affecting, but Annex does it in a much more interesting way, so it can more precisely figure it out. I'm not going to cover that. I showed you a bit of the VS Code integration, but there is a lot more you can do with it, and there are other things that help you scale your development, beyond a handful of projects to much larger repos, right? But to summarize, so what we got in here is the repo that's sort of analogous to our Lerna repo, right, in terms of what it does, right? It's a bit different in terms of how files are laid out, but fundamentally it's very similar. Okay, so there is not much going on in here that's different from the Lerna one. Right? We got it, we scaffolded it. The dev experience and the build or the execution experience are both correct in this case, right? I can navigate around in the editor, but when I build, I consume stuff from this. And I also get a beautiful thing that I showed you, which is called Computation Cache. In this case, it's distributed as well. And there is nothing analogous to Computation Cache, really analogous to that in Lerna. Folks do sort of bespoke things, right? But it's quite hard to get it right, especially once you involve distribution and things like that, okay? So now we have this, and let's say we like this. Let's say we like this, what we get here, in particular Computation Cache. Perhaps we want to scale it to to a much larger repo, we want to sort of use this for development, but we already have a Lerna repo. Now the question would be, is it challenging to move the Lerna repo we saw to Onyx? Right? What are the steps involved? Are we talking about weeks or months or days? Right? So let's take a look. All right. So in this case, we created again an empty Onyx workspace, and we're going to copy our Lerna stuff in here. Okay, so there are two directions in general to go. We can either create an empty workspace and move the code over, or we can create configuration files for Next and copy them into the Lerna repo. It doesn't matter. It's exactly the same stuff. It's just if I do it this way, it's easier for me to show progress. Right? The same progress happens in neither direction. So, it's possible to do all of this, preserving your Git history, so that's not an issue. Okay? So have an empty Next workspace with a list of packages, right? And what I'm going to do now is I'm going to copy the files from the Lerna repo. And this is what I just did. So I copied the two folders. There is an app folder and the header folder, and I copy them as is, meaning that they're not created by the Onyx plugin. They're basically what we had in Lerna repo. So right now the folders are here, but it is not runnable, right? Because Workspace, the JSON is empty. So we have the files. We need to teach Onyx what to do with those files, like how to test them, how to build them, or whatever, right? And this is what I just did. So I copied the two folders, app and header, right? Both of them right now in the packages folder. And so they're not generated by Onyx. This is our Lerna stuff, just copy and paste it, okay? And so the folders are here, the files are here, but the configuration file, the workspace, the JSON is empty. So Onyx doesn't know what to do with them. It doesn't know how to test them. It doesn't know how to build them, right? So we need to teach Onyx what projects we have and how we can interact with them. So normally the bulk of this file would be created for you by plugins, and you can then modify stuff if you want to reconfigure your projects, right? In this case, we are not using the plugins, so we need to configure the project section ourselves. And this is what I just did. Okay, so I essentially created two projects here, one for header and one for app, and I point to the source where the projects live, all right? And then I created this set of targets for each project. In this case, it's only build and test. But instead of using like the specific Jest plugin or the Webpack plugin that Onyx offers, I'm just using the run commands utility, the builder. And this run command thing essentially just invokes a command or a series of commands, right? So in this case, we're invoking the existing npm script, and in both cases. So in terms of build and stuff, none of this has changed. So I still have my Webpack scripts in here. It's all exactly the same. My rollup configuration is still the way it was in the Lerna repo. I basically just told Onyx, hey, when you invoke Onyx build header, invoke that script. And Onyx is going to invoke that, and the rollup will be picked up, right? So that's sort of automatable, right? You could do that very quickly, point at every at your projects and describe npm scripts, right? That's essentially what I did. But the result of this right now is already quite good. So everything I did so far is very easy. I copy the files over and just point to npm scripts. But the result is quite good, because now, even though this is what I did, I can already do things like Onyx run many target tests all in parallel, right? I can already do this. And so I can already run my npm script, and as you can see, the caching already works, right? So I didn't have to do anything anything special to enable caching, right? Because the property like computation caching in this case is generic, right? You don't have to use any plugins to make it happen. It just happens by itself, right? In this case, the caching already works both for test and for build. You can do the same for build, right? And as you can see, the output matches our Lerna output, and again, it's cached, right? So that already works, and the code analysis works. So Annex already knows without my having to do anything. I just point to folders that the app actually depends on header by itself, by analyze, by sort of figuring out by looking at the source code, right? And that's sort of the step one of the migration. You move the code over, right? You just point to scripts, and suddenly the caching works, and your system can already be like a lot more scalable, right? You don't have to recompute stuff over and over again. Okay. So finally, let's change this configuration to use the plugins that Annex offers. And this is what I just did. Okay, so I replaced the npm scripts, so you can see my app no longer has anything related to the build stuff with existing plugins. So I basically specified when you want to build a header, use rollup, some configuration on how to do that. If you want to test, just point to the configuration, and same for the app, right? So I don't want to go into details of every property over here. You can, look it up online. The important thing is that this configuration is not like massive, okay? So it's fairly small, and it's usually not that difficult to go from a bespoke Webpack setup to, to something like this, because you still can provision, augment Webpack configuration to match your needs, okay? All right, so we look at two build tools, Lerna and Annex. We start with the Lerna repo that has two packages, the header package and the application package. And the app in this case depends on the header, right? So the idea there was to build the header first before we can build the app, right? So we can do things incrementally. So we can build much larger systems in this way. Lerna by itself doesn't give you the whole story, right? So most folks who use Lerna for very large repos have to come up with some way of reusing computation or figuring it out or whatever, right? It's more challenging than it may seem at first, right? So the naive solutions most folks have don't work well, right? What we look next then is the issue with two contexts. There is the editor context, right? Where when I edit, I want to look at source, and the build context where when I build, I want to actually look at the dist. And again, even though it's possible to get it right, sort of when you look at the tutorials that just always point you to using star to link all the packages, that doesn't work. Okay, that in practice is not a solution. It's possible to get both of those kind of work, but it's a lot of manual work, right? Then we created the same or a very similar system with Annex from scratch. And I didn't show you a lot of the tooling stuff, right? But the CLI and the VS Code experience and a lot of other things like dev graph visualizations, GitHub integration, all this stuff is amazing. Actually enriches your dev experience quite a bit. So, just believe me, it is there. Look it up online. If you into having a more integrated dev experience, Annex obviously offers a lot more. So we look at that. And the main thing, in addition to the dev experience part, was that we have computation cache. Right? That now, instead of rebuilding stuff over and over again or trying to come up with some heuristics when not to, we actually have a reliable way to skip recomputing stuff, right? Either tests or builds when we know the results will be the same. And we can share that cache with our teammates and with the CI. And that's the biggest deal, right? Much larger systems can be built when that piece is reliable, right? Then we looked at the transitioning from Lerna to Annex, right? Say if we have a Lerna repo, how hard is it to add Annex to it? And actually, you can use both at the same time, right? You can still have Lerna and some of the folks we work with do it, and have Annex on top of it for the computation caching part and for the plugins, right? Nothing prevents you from having them in the same repo. Just often, if you use Annex, well, at some point, Lerna becomes unnecessary, right? And we look at two stages in this case to transition. The first one is sort of stage one or step one is, use run commands. Right? Essentially, we move the code as is. We just tell Annex where the code lives and what npm scripts you have, right? And with that, we already get the code analysis, computation cache, and like sort of 70% of the value, right? Step two, use plugins. If you start using plugins, we or the community offers, you don't have to maintain your own build or test stuff, which is nice, but also things like the editor context, the execution context, all of those things work correctly, right? Because the plugins take care of that. If it is interesting, if you want to check it out, play with it and see if it's a good fit for your work or for your project, go to annex.dev/react. Annex is not a React specific tool, you can use it for pretty much anything. But if you're interested in the React stuff, go there, check it out, watch the tutorials, watch the course we have, the free course on Egghead, play with it. And if you have any questions, reach out. Thank you.